Here I've got a nice integral that comes from the 1980 Putnam. And you know, whenever you see an integral in the Putnam exam, then there's probably some sort of trick in order to evaluate it. Like you'll never really use any of the methods that you learned in Calculus 2. It's probably some sort of evaluation via symmetry or something else like that. Okay, so let's see what we've got. We want to find the value of the integral from 0 to pi over 2 of 1 over 1 plus tangent of x to the square root of 2. Okay, so let's look at this and really keep in mind that there's probably a trick. And like I said before, it might involve symmetry. So how could we let it involve symmetry? Well, maybe we could split up this interval from 0 to pi over 2 into two pieces. And so maybe we would write this thing as the integral from 0 to pi over 4 plus the integral from pi over 4 up to pi over 2. Okay, but if we're doing that, we probably want to do some sort of change of variables to make those two things look the same. Okay, so if we were to do a change of variables like that, then we would maybe need some sort of trig identity. So maybe this would be a good idea of a place to pause the video and maybe play this game to see if you can finish it off. But I'll just jump right into the solution. So I want to use the following fact, and that is that tangent of pi over 2 minus theta is equal to 1 over tangent of theta. Okay, great. So keeping that in mind, we can actually use this sort of separation of the integral in order to evaluate it quite nicely. Okay, so I'm going to take this and write it as I, just for notational convenience, and then I'll take I and rewrite it as the integral from 0 to pi over 4 of 1 over 1 plus tangent of x to the square root of 2 dx plus the integral from pi over 4 to pi over 2 of the same thing at the moment. So we've got 1 plus tangent of x to the square root of 2 dx. And now I want to do a change of variables in that second integral. So the change of variables that I'll do is I'll set x equal to pi over 2 minus y. But that means that dx is equal to minus dy. Okay, so let's see what that does to our setup. I'll just bring this first integral down. I have the integral from 0 to pi over 4, 1 over 1 plus tangent of x to the square root of 2 dx. Then I have plus the integral of 1 over 1 plus tangent of pi over 2 minus y, and then I'll have that to the square root of 2, my dy component, which changes this to a minus sign. Now let's see what happens to our bounds of integration. When x is equal to pi over 2, y will be equal to 0, because we can just reverse this a little bit and see that y is equal to pi over 2 minus x. So that means my upper y bound is equal to 0. And then likewise, my lower y bound will be equal to pi over 4. But in order to simplify that a little bit, I can change the order of integration and change this minus to a plus. And now I've got two integrals that are evaluated from 0 to pi over 4. Okay, so now let's see what we can do from there. I can use this trick over here to rewrite this tangent of pi over 2 minus y as 1 over tangent of y. Okay, so let's see what that gives me. I'll just bring this guy down. I have the integral from 0 to pi quarters of 1 over 1 plus tangent of x to the square root of 2 dx. And then I have that is added to the integral from 0 to pi over 4 of 1 over 1 plus, well, it's going to be 1 over tangent of y, but from this step to the next, I'll make the trivial substitution of x equals y just to make it look like this first integral. So I have 1 over tan x to the power of the square root of 2, and then that's going to be dx. Okay, so now let's see if we can simplify this second term. Well, we can multiply the numerator and the denominator by tangent of x to the square root of 2, leaving me with tangent of x to the square root of 2 over 1 plus tangent of x to the square root of 2. Okay, but now if we add these two integrals together, we'll see that we get the integral from 0 to pi over 4 of 1 plus tan x to the square root of 2 over 1 plus tan x to the square root of 2 dx. So here we have 1 over 1 plus tan x to the square root of 2, and then tan x to the square root of 2 over 1 plus tan x to the square root of 2. But clearly, this integrand just simplifies down to the number 1. So if we integrate the constant function 1 over the interval 0 to pi over 4, we obviously get pi over 4. And that's a good place to stop.